see, we have the formulas x of k equals 2 u sub k and h of k equals 3k u sub k. And so we're going to be doing the convolution sum of that to get y sub k. And this is what you use for discrete convolution. So we have y sub k equals the summation from infinity, well, from negative infinity to infinity of 2u sub m, because it's x of m, and 3k minus m u sub k minus m, because you always want to flip and then shift your h. So from the u sub m, we can get our bounds for the convolution, so we don't have to be going from negative infinity to positive infinity. So from u sub m, we get m is greater than or equal to 0, so our bottom bound will be 0. And then from the u sub k minus m, we get k is greater than or equal to m, so we go to k. So our new summation is going to be 6, because we can pull out the constant, summation from m equals 0 to k of k minus m. And so if we want to solve for like y sub 0, we do 6 summation to 0 from m equals 0 of 0 minus m, which is just going to be 0. And y sub 1 will then be 6 summation from m equals 0 to 1 of 1 minus m of 6, which is just going to end up equaling 6. In the same format, y sub 2, when you solve that out, is going to equal 18. Okay, so then from there, we can use, if you don't really want to do the long process of figuring out the sum every single time you want to know, like, if you want to try and figure out what y sub k is in a shorter method, you can use summation formulas. And summation formulas are just formulas for summations that can be found online or in the back of most discrete textbooks. If we want to use summation formulas have to be used in a set way. So what we're going to do is we're going to take our 6 summation from m equals 0 to k of k minus m, and we're going to separate that out. So we're going to have 6 times k times the summation of m equals 0 to k of 1, because we can pull k out because k is a constant. And that's going to minus the summation from m equals 0 to k of m. So the summation from m equals 0 to k of 1 is going to just turn into our upper bound, which is k, minus our lower bound, which is 0 plus 1. And that's just the formula for any summation of 1. And then the summation of m is going to turn into our upper bound of k times our upper bound plus 1, so k plus 1, all of that divided by 2. So then when we factor all of that out, we get 6k squared plus 6k minus 3k squared minus 3k. And so that's going to be y of k equals 3k squared plus 3k. So if we want to check ourselves to prove that this works, we can have y of 0 is going to equal, plug in 0 for k, and we'll have 0 plus 0 equals 0. Y of 1 is going to equal 3 plus 3 equals 6, and y sub 2 is going to equal 12 plus 6 equals 18, which if you look back previously on what we solved for y sub 0, y sub 1, and y sub 2, those are the same. So that's a basic example of how you can use convolution sum and some of the shortcuts you can do. Thanks for watching.